we're going to do a roadmap from chapter 12, which means it's a general review of all the reactions in Chem 241. And they show up on all your tests. So this is not a waste of time, trust me. We have ethane in the start here, becoming ethyl chloride here. Now, ethane is not a very reactive molecule. And the only way we can do it is we're using radicals. This is a chapter 7 reaction. I'll put chapters above. And that's chlorine gas. You don't need to know it's gas, but you need some form of heat or radiation. Remember, this is the one that goes initiation prop 1, prop 2. And then you're going from here to here. You're getting rid of H on the beta and leaving group on the alpha. That is the calling card of elimination. Elimination on a primary carbon with a leaving group. You can accomplish any elimination on a carbon with a leaving group as long as you use a strong base and heat. You can even use your simple strong base KOH and heat. Here the heat is for the endothermic reaction to make a pie. Just keep going all across the top. We've got our pie. Now I got to do a hydroxylation on the end and an H on the other end, which is hydration. You got many options here because it's not about Markovnikov with this example. Same substitution both sides. Why don't you go the first one you ever learned? H2O, H2SO4. Acid catalyzed hydration of an alkene. You could have used the mercury one. Mercury acetate, mercury 2 acetate, followed by, don't forget you have to have water with the mercury 2 acetate, followed by NaBH4. Or you could have done the other one, which is hydroboration and oxidation. All of those found in chapter 6. Sorry, the elimination was found in chapter 9. Oxidation of alcohols found in chapter 10. You need to use PCC here. I'd like to point out there's a biochemical equivalent that you can actually use here too, using NAD+. That's also found at the end of chapter 10. You'll learn more about it in biochemistry this semester. Okay, now let's go from here down to here where we do some synthesis. We need to put a new group on a carbon that has a leaving group. You need a nucleophile. The nucleophile is called, C+C minus nucleophile is called acetylide. You could put a solvent there for SN2. It's not mandatory. This one, I gave you the solvent for an SN2. I was trying to help you. I was telling you it's an SN2. If you see acetone or one of the 4 solvents for SN2 and you don't remember your solvents, then you're missing clues. Okay? We don't like missing clues. SN2 on a carbon with a leaving group. Same as the previous one, but this time I want the product. You got an SH here. SN2s are found in chapter 9. Okay. Now we're doing more synthesis. I'm going down here. Well, how did you do the first synthesis? You had a C- attack a carbon with a chlorine. I need this to be a C- so it can attack a carbon with a chlorine. How do you make this into a C-? My favorite way is KH. Step 1, make your nucleophile. Step 2, add a isobutyl group with a leaving group on it. So Br or Cl attached to isobutyl. You're saying, why isobutyl? Well, this is an isobutyl here. Okay, that's all found in chapter 7 and 9. Chapter 7, for the acid base and synthesis. Chapter 9, further review of the SN2 reaction used in the synthesis. All right, and the next one, pKeq is -6. Well, you better know the pKa of a thiol. We got a lot of review going on here. pKa of a thiol is 10. So we're going to make some acid here, HA, with a pKa equal to 10 minus X equals -16. -6, sorry, X equals 16. 10 minus 16 is the only thing that gives -6. Water is the acid. HA is water. So please put its conjugate base in the box. Okay? That'll be the base reactant. And guys, that's chapter 4. Acid-base chemistry. Mixed with our new pKa found in chapter 10. Thiol. Thiol. pKa 10. All right. Wandering all over the place here. Hey, here's one that's, it's a review, but we reviewed it here too. That's a per-carboxylic acid. We only use per-carboxylic acids to make epoxide. Epoxide. Right there. And there's the 2 carbons of the epoxide in this molecule here. It got attacked by a nucleophile. I'm just moving down here. Making epoxides, chapter 11. Opening epoxides, also chapter 11. We're going to use them on every test almost. Well, let's just use them every test. You need the piece that's here that's not blue or green. Well, this is the piece, and yes, we're using acetylide another time. Right there. It attacks the least hindered carbon of the epoxide, but in this case, that does not matter. Same substitution, both sides. Epoxide opening, you get 2 new carbons with a new OH on the end, one away from where you attacked. That's very handy. Carrying on downwards, D2PD calcium carbonate PbSO4. That's a chapter 6 reaction, 7, sorry. This combination here is called Lind-Lars catalyst. And it's good for making a syn addition of deuterium. It would be hydrogen if it was H2, but it's deuterium. The rest of the molecule did not change. Okay. And look at those D's on the same side there. Oh, wow, what's going on here? Yeah, it's a great, we had a question about that. What happened? It's a good question. All right. Well, there's a little less happening than you think. I'll do some numbering for you. Some numbering in light pink here. We got the alcohol, carbon 1, 2, 3, 4. Got the alcohol on carbon 1, 2, carbon 3 is going to have a Br. Carbon 4 has a new bond to oxygen. Hey, if I can make this into a triangle with a Br on it, then I'll attack one of the carbons. Now, most of you say, okay, if you do that, Dr. Whitaker, that's great, but you want to attack the more substituted carbon, because triangles open that way. The bromine triangles and the chlorine triangles with the plus charge on them, those are the ones that open on the more substituted side. But if you did that, you'd make a ring size 4. Want me to count for you? Here. O. The O is going to attack a triangle here. So O, 1, 2, 3, 4. If you have a choice of making ring size 4 or 5, I don't think it's about carbocations anymore, right? It's about rings. So, guys, all you need to do is add bromine, is what I'm saying. Br2. That makes a triangle. And Br2, we learned Br2 with water. The water will attack the more substituted carbon. We also learned alcohols do whatever water does. This molecule has an alcohol. The bromine will make a triangle. Br2 will make a triangle. And then the alcohol will open the triangle. And the alcohol is already on the scene. You don't have to add it as a molecule like we did with water. And that's a chapter 6 reaction. I'll put a star because it's, chapter 6 with a modification, because we used an alcohol instead of water. And then, since we're here, what did I say about when I give you something like dimethyl sulfoxide, one of our 4 solvents in chapter 9 that are called polar aprotic? You're doing an SN2. Well, you need a carbon with a leaving group. Check. You need a good nucleophile. Check. You need to remember it's a backside attack on this carbon right here. To show me that you know that by doing this. This is SN2, chapter 9. Copy your ring. This didn't get touched. The azide came in from a wedge. N doesn't say I have to draw out azide, so I can do it like that. And the D got pushed back. Backside attack pushed it back. There you go. Preview reaction. Oh, I don't have those on the top of the screen or anything. Oh, man. So this would be, you consider something like this a bonus. You say, I have no clue, Dr. Whitaker. Never seen it before. You're going to have reactions like that. Roadmap has almost twice as many points available as they count. I'll just tell you, roadmaps in this course, every test, 25 points. How many points are available every test? Probably 40, 40. And if you get them, you get to keep them. Yes, really good students can get 40 out of 25. So it's okay to have reactions you've never seen before, right? I know it's frustrating, but it's going to happen. So take a stab. I need to put H's on the molecule. H's. It's a reduction. What do you think happens to the other 2 nitrogens? Just whenever you say 2 nitrogens, as soon as I say, what happens to the other 2 nitrogens? Like, this is the first thing that comes to my mind. Just look at the product. There's only 1 nitrogen in it. N2 gas is the best leaving group known to man and woman. Okay. So I need to put hydrogens on, and this thing's going to go on its own. It's basically H2 and PT. It is a preview of a chapter 9. You want to get official on it? It's a preview, chapter 23. Okay. You could also use or. Have you seen any other replacements for H2PT that we are responsible for, everybody? Yeah. There's a boron involved. Step 1, NaBH4. Step 2 is always what? H- nucleophile is going to create thing, and then HCl is going to provide your protons for the N-. Okay, so you can use H2PT or NaBH4HCl. And that, believe it or not, is the end of the street for that. We left off here and didn't finish this one. We made this internal alkyne. Sodium and ammonia, we learned in chapter 7, is going to make a trans-alkene. So we'll have an ethyl on here and an isobutyl over here, and they're trans. Now this one's like the one we talked about here, but this one has the water. I'm looking for my eraser here. No, that's too big. It looks like this thing's attached to my CO2. There we go. Not. Okay. Chlorine and water, chapter 6 reaction. You're going to make 2 products here. And it's a dead end. No, it's not a dead end. Whoa. So you know what I'm saying here? I'm saying we're going to need something like this. OH, Cl, Ibu. You want to get picky. We should show that we know they're opposite sides. That's a vicinal halohydrin. Because the substitution's the same, you could have switched the OH and the Cl. There's not one carbon that's more substituted than the other. I don't know how to add that, so I'm just going to verbally say you could have the OH down here and the Cl up here, and you'd get full credit. And what happens when you react this with reagents to get that? Well, how do you get this to happen? Ladies and gentlemen, all that's happened is the O lost its H, the O minus that you made attacked the carbon with the leaving group in an NGP fashion, and you made an epoxide. So if you can make the O into an O minus, this reaction's over. And that's just acid base. KOH. You can use KH, KNH2, some strong base. Give me a strong base there. That's it. And that was found in chapter 11. This step is like there's an NGP involved, making a triangle. Now we're going to open an epoxide. With what? What's new? Well, this is new. In more ways than one, that's new. It's new in the molecule, NEW, and it was a nucleophile new that attacked. It's cyanide. Mr. Mohammed saw that happen a mile away. He knew that new was going to come twice. All right. So that opens it up. And you're going to have an O minus, right? You're going to attack right here and make an O minus. That O minus needs to be OH. So step 1 is to open it. What's step 2? I got to put a proton on it. What's our favorite acid for putting protons? HCl. Opening epoxide. Attack with a nucleophile. HCl step 2. Grignards on aldehydes and ketones. Grignard reaction first. HCl step 2. Organolithiums and aldehydes and ketones. React the aldehyde or ketone with the organolithium. Step 2. HCl. Sodium borohydride. What's always step 2? HCl. Lithium aluminum hydride. What's always step 2? HCl. Keep watching the video over and over until it sticks. Okay? And now we have our opened up thing here, and the OH is becoming a carbonyl. You are gaining a bond to oxygen. That's called oxidation. Secondary alcohol oxidation is the easiest one of all. Any chromium in this box is going to get credit as long as it's real. Okay? Don't just write Cr. You get nothing. It's got to be chromium with the right oxidation state. You can go PCC, save some time, waste some money, but that's okay. I'm going to do it. Oops, that's a P. PCC. I've been skipping stuff. Chapter 11. Oxidations, chapter 10. PCC could be replaced by CrO3H2SO4AQ or K2Cr2O7 H2SO4AQ. We have to be rock solid on all the chromiums. Okay. Preview reaction. Take a wild guess. It's the same answer as our last preview reaction. You're reducing C pi bond to N twice. H2 comma PT or 1 NaBH4 2 HCl. Chapter 23. And end of the street. This was not the end of the street. This is a funny one. I want this product copied here. Look, I use these chemicals on this molecule. I said, if you use these chemicals on this molecule, you get this result. So guys, don't waste your time. Here, big label A. Here, A's in the box. I like it. Okay, big roadmap, big roadmap. We never did alkyne, terminal alkyne, becoming something. You make an enol on the more substituted carbon, and then it undergoes that fancy word, the enol undergoes tautomerization to a ketone. So, ketone here. And 1, 2, 3, 4. End of the street for that one. That was a chapter 7 reaction. Did I miss one down here? 8. Well, chapter 10. Here we go. Oh yeah, this is the complementary reaction here. You make another enol, this time on the less substituted carbon, and then it undergoes tautomerization. So your carbonyls at the end. And that's also found in chapter 7. And ladies and gentlemen, you see a reaction that makes a ketone, and you just studied a whole chapter on aldehydes and ketones, and you don't think this is particularly important, then you're not getting the point of organic chemistry. Anything you learned previously about aldehydes and ketones is particularly relevant when you're studying just aldehydes and ketones. So you have to review those reactions. Okay. What's going on here? There's a chapter 6 reaction with ozone. Remember the ozone, you do your big cut. You get a carbonyl on each side. You get a carbonyl there, and a carbonyl down here, and an ibu over here, and an ethyl here. There you go. 3 C's on top, 5 C's on the bottom. Cool. Uh-oh. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and then 6, 7, 8. 6, 7, 8. Yeah, we're cool. Hey, DMF, what did I tell you? When you see DMF on the page, what are you thinking about? SN2, I like it. Chapter 9, backside attack, leaving group leaves, stereo center flips, a lot of good stuff. The sulfur is the nucleophile, comes in on the dash. No, it came in on the wedge. Opposite of what it broke off. It pushed the H down to a dash. There you go. Has to come from the front because leaving group's on the back. End of that story. What do we got going on here? Oh, I don't even know. I can't follow this yet, just yet. We got PCC here. We have this. We haven't made this yet. How can I have this become this if we haven't made this yet? I need a roadmap for my roadmap is what's going on. Yeah. Where'd this come from? This guy just showed up on the page, didn't he? Seriously, he just came from nowhere. He's not like a start here or anything, but it is another alternate start, I think.
Oh, yeah.
This.
Yeah.
Oh, it's not ran. Oh my goodness! Wow. See, I sympathize with you guys. Yeah, I got too inspired. I just thought there was random stuff going on. Oh, it's our favorite. We even did the review mechanism. Somebody made me do it. To make the DHP protected alcohol. What? DHP protection. I think that's found in chapter 10. I need DHP is what I'm saying. Dihydropyran with a strong acid catalyst, either sulfuric or toluene sulfonic. Just a little reminder, that's DHP. Right there. And now it's got an O that's not got a pKa of 17. So you're not taking an H off this O with this base, are you? You're taking an H off the terminal alkyne, 25. There's your nucleophile, everybody. Here's where it's time to do an R. We haven't done a single R. R. So R is attached to C242 is attached to a carbon. CH2 goes down to a C that still has a wedge O dash H and a methyl because there's a backside attack on this carbon right here. Put a dot on it. Yep. And what does step 3 do to the O minus that's right here? Because step 2 puts an O minus right here. Opening epoxides is always followed by HCl. There's an echo in this room. I swear I said that before. Okay. OH is what you get. That's the purpose of the HCl, is to protonate your alcohol. Yeah. OH little. Oh, not that H. What am I erasing? Oh, the extraneous stuff off the H. Save. Save and run. Apparently my cut paste job wasn't so cool here. I gotta do an edit. That's just OH, I'm pretty sure. How do you take an alkyne and make it into an alkane? That's what's happening. Hey, don't waste money on Lindlar's catalyst this time. You want to reduce both pi bonds. H2PT, end of story. Chapter 7 also. Okay. Primary alcohol with one of the chromiums that generates chromic acid. What are we putting in there? What functional group? Yeah. You're not getting any points if you put an aldehyde. Here, 0 points. Sad. Sad face. 1, 2, 3, 4. 1, 2, 3, 4. No, this is the one that hydrates first and makes a hydrate, and then one of the other alcohol attacks the chromium. It's a carboxylic acid, people. We have to know that primary alcohols with chromic acid, these generate chromic acid. I'm not saying they are chromic acid. I'm saying they generate chromic acid. Primary alcohol, ROH, chapter 10. Have to review it. You can't not review chapter 10 in this class. Things will not go well. That's oxidation to a carboxylic acid. Okay. Here is a chapter 10 reaction as well. Still got the dihydropyran protection here, and we're changing the OH to an OTS. You may think the stereocenter's changed. You would be wrong. This is S. This is still S. Not about the stereocenter changing here. It's about making a tosylate ester. Paratoluene sulfonate ester. OTS ester. You need TS attached to? Yes, TS attached to Cl. And pyridine. Both those short forms are acceptable. They're very common in organic chemistry, but you should know what they look like. You should be able to draw both of those, please. It might show up on your task randomly, without notice. And I gave you notice. Okay. All right, how do you make an alkyne into a transalkene? We can do that first. We've already done it on this page. This is not a new reaction. How did we make an alkyne? I gotta find it. Yeah, alkyne into a transalkene. Chapter 7 says use Na and NH3. That's step 1. Na comma NH3. Please do not put the NH3 right beside the Na. Okay, that gets your transalkene. Now I got to get rid of my DHP protecting group. Remember, you put on the DHP protecting group with DHP and a strong acid catalyst. If you're going to get rid of a protecting group, you have to use the same catalyst. There's part of it. Putting groups on and taking groups off often involve the same catalyst. But you need to also provide something that breaks the molecule apart in a reaction called hydrolysis. What is the only molecule that can break things apart in hydrolysis? Water. There you go. Okay, now I need a chemical that converts a primary alcohol into an aldehyde. Do not give me anything that makes chromic acid. We already established things that make chromic acid with primary alcohols make carboxylic acid. Do not give me anything that makes chromic acid. Give me another chromium, please. PCC. Step 1. PCC. Step 2, your S stereocenter is now R with a new group on it. You did a backside attack on your OTS ester. OTS minus LG. Secondary RX. Strong nucleophile, CH3O minus. You want to put acetone in there just to be good? Fine. DMF, great. Acetonitrile, whatever. Use one of the 4 SN2 solvents. It's not mandatory. I need the nucleophile. All right, so I left off without a lot of chapters. Making the transalkene, chapter 7. Deprotection of DHP, also found in chapter 10, where protection is found. PCC found in chapter 10. SN2 found in chapter 9. And we are slowly approaching the end of this arduous road. And I still can't remember how the heck we got anywhere in here. Yeah, we are down here. Did we get there?
Yeah, you need the reagents to get there.
We need the reagents to get there. I don't see anything pointing towards this thing, do you?
Left to the right and up to
Yeah, that gets from there to there. I still think that this guy appeared from nowhere.
No, we got that from the left.
We're going to keep having the same discussion over and over. It doesn't matter. Just fill in the boxes, everybody. Stuff could be just appearing randomly. Did anything happen here? Let's just do this. Yes, we have a new group on a terminal alkyne, don't we? How did you get a new group on a terminal alkyne before? There's a terminal alkyne. There's a new group. Here's a terminal alkyne. Terminal alkyne with a new group on it that's an ethyl. Yeah. You need a C minus and a ethyl with a leaving group. This one I need a C minus and a epoxide. I don't think I need an epoxide here. I don't see any oxygens over here, right? So 1, make the C minus. 2, chloroethyl. There you go. Chloroethane, DMSO. It's an SN2 reaction again. And then we got to deprotect our alcohol. Isn't that what that is? We've done that already. That was step 2 here. And I put a little, that's DHP, deprotection. Found in chapter 10. So I need DHP, deprotection. Where am I? Yeah. Up here. Where was I going? Oh, from here to here. Yeah. DHP, deprotection. H2O, H2SO4.
Is the deprotection the same as the acid catalyzed hydrolysis of ether?
It is. It is an acid catalyzed hydrolysis of ethers. Yes. She asked, is it the same as an acid catalyzed dehydration? Hydrolysis of ethers, and it is. And also chapter 10. Put a double a telephone pole here because it's the same reaction again. And then this thing's becoming this thing. Oh, hey, I'm a broken record. I need this O to attack a carbocation right there, because that would make this. How do you get a carbocation right here? How do you make a carbocation from an alkene or an alkyne? No, you gotta protonate it. That's it. Protonate. And this is a cat. It's the same as acid catalyzed hydration of alkene. You're going to put a triple telephone pole in green. It's the same reaction as acid catalyzed hydration, except you're using an alcohol in place of water. This is not the first time on this page we've talked about this. We're doing an acid catalyzed hydration of an alkene, and it was making this ring. Oh my goodness, I can't remember where it happened. It's on here somewhere. I want to put this triple telephone pole. I don't even know if this thing. Where it happened before. Is it this one? This thing? No. When did this ring show up first?
I think what down when we had the bromine.
Is there bromine? I'll find it later. I don't want to waste your time. We did it. That I remember. Now this one, you're adding an H here and an H here to an alkene. We did it with alkynes already. H2PT. Chapter 6. Hydrogenation of alkene. And we're getting there. We got the stream on the far right here. What happened going here to here? I don't know what R looks like anymore. I forgot. Oh, let's see. We have this portion right here. We have the triple bond right here. We got to get CH2, CH2OH again. Is this the third time on here? I think so. How do you get rid of the DH? It's getting rid of the DHP protecting group. How did we do it the other 2 times? It's got a triangle, telephone pole on it. You can put it here again. H2O, H2SO4, chapter 10. Got rid of our DHP protecting group. How do you make an internal alkyne into a cis alkene? We learned how to do that in chapter 7. It's already on the screen somewhere. Yeah. Where's the Lindlar? Where'd you go, Lindlar? There. Chapter 7. It's going to get a new symbol. How about a double? And we'll put H2, comma, double star. Or in chapter 7, you also learn BH3, CH3CO2H works. Hydroboration protonolysis. Here's your double star up here. Lindlar's catalyst, okay? Right there, I just added it. Hot, heat, that's funny. Let's see, I have alcohols. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's multiple answers here. If you make a cation here, you can attack it with this alcohol, which you'll make with sulfuric acid. Toluene sulfonic acids make cation here and here. I'll accept either answer because they make ring size 5 from here to here, or ring size 5 from here to a cation there. I'll do the one that's easier to draw. You got the O with a new bond here, comes up here, 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 and here. And does it fit the formula? Probably. C1, 2, 3, 4, 5, 6, 7, H1, 2, 5, 7, 8, 10, 12, 14. Uh-oh. Is that right?
There's only one total.
Oh, there's only one O. What did I do wrong? Oh, hots and heat. Hots and heat. I didn't see the heat. The heat is on. That's an old song from my days, guys. Just bear with me. What happens with alcohols in hots and heat? It was the very first thing we did. Seriously, the very first thing, well, one of the very first things we did. Maybe I lied. It was up here somewhere. Maybe not. No acid catalyzed dehydration of alcohols anywhere? I lied. Not on purpose. Chapter 10, acid catalyzed dehydration of alcohols. I would consider this like a bonus question. There's a lot going on in this one. I think you're going to get more of that. Well, probably up there. Trans. But if you get down to this part where I just said it was like kind of the bonus round, you're probably going to get half credit for this and full credit for anything like this. You could have made the ring from here down to here and then done the dehydration here. You want me to give you that result too? Double bond here, goes to that, goes to an O. Oh, this is going to be a nightmare. Why did I even say I was going to do this? Yeah. I did it.
On the entity, you only have the ring with a pi bond and just one branch sticking out.
Oh, wow.
And we have plus water. Oh, yeah.
Yeah, we got the plus water. And then 1, 2, 3, 4, 5. Okay, we got the 1. We got the 2. Do we have the 2? No, we don't have the 2. 2. And 3, 4. 3, 4, and 5. And what's off 2? We have a methyl. Stereo center didn't change. There you go. That's another product that has the same formula. Okay. And that was exhausting, but I hope worth our time. Oh, sorry.